The morning of November 19th, 1942. Outside Tobruk, Libya, the captured American vehicle sat abandoned beside a destroyed British supply column, its crew having fled when German armour rolled through at dawn. Oberfeldwebel Klaus Richter circled the small, boxy machine with the practiced eye of a man who had spent 15 years maintaining military vehicles. The placard on the dash read Willys MB. His unit called it a Jeep. Richter had seen plenty of enemy equipment during the North African campaign: British trucks that overheated in the desert, Italian vehicles that broke down constantly. But this American machine was different. He could see it in the engineering before he even turned the ignition. What he couldn't see yet, what none of them understood until Richter engaged a small metal lever beside the driver's seat, was that this vehicle represented a fundamental philosophy that would reshape their understanding of modern warfare. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The concept of four-wheel drive wasn't new in 1942. The Dutch Spyker had demonstrated all-wheel drive automobiles as early as 1903. The American FWD Auto Company had been producing military trucks with powered front axles since World War I, but these were typically heavy trucks designed for extreme conditions, not light reconnaissance vehicles intended for frontline service. The German military's primary light vehicle, the Volkswagen Type 82 Kübelwagen, represented the conventional wisdom of 1942 automotive design. Ferdinand Porsche had engineered it as a military adaptation of his Volkswagen civilian car. The Kübelwagen was an excellent machine by most measures. It weighed 1,540 pounds, roughly 900 pounds lighter than the American Jeep. Vulnerability of liquid-cooled radiators to enemy fire and freezing temperatures. It achieved superior fuel economy, managing roughly 36 miles per gallon compared to the Jeep's 16, but the Kübelwagen had one critical limitation that defined its capabilities in every theatre where Germany fought. It was rear-wheel drive only. Richter knew this limitation intimately. He'd spent the past 4 months maintaining his unit's Kübelwagens as they struggled through conditions that German engineers in Stuttgart had never anticipated. The standing order for captured vehicles was simple. If it couldn't be immediately useful, destroy it. But Richter's commanding officer, Hauptmann Ernst Weber, had developed a policy of examining enemy equipment before destruction. "Get our best mechanic," Weber had ordered when the Jeep was discovered. "I want to know what we're dealing with before we torch it." Richter approached with 2 junior mechanics, Gefreiter Hans Müller and Obergefreiter Otto Schneider. Together, they represented probably 200 combined hours of training in military vehicle maintenance, focused primarily on German equipment. The Jeep sat at an angle in the sand where its crew had abandoned it. No visible damage, no obvious reason for abandonment beyond the tactical situation. Richter walked a complete circle around it first. The body was simple, almost crude compared to the Kübelwagen's carefully shaped panels. Flat steel plates welded and bolted together with no attempt at aerodynamic efficiency. Everything about the design suggested speed of manufacture over aesthetic consideration. He opened the hood. The engine compartment revealed something remarkable. Every component was clearly labelled with stamped metal tags. The wiring used colour coding, each circuit a different shade. The oil dipstick was painted bright yellow. The radiator cap was red. The battery terminals were marked positive and negative with raised lettering. In 15 years of servicing German military vehicles, Richter had never seen such obvious design for field maintenance by non-specialists. Müller peered over his shoulder. "It's very basic, almost primitive." "No," Richter corrected. "It's intentional. Look at this." He pointed to the spark plugs, which were identical and accessible from above without removing any other components. They've designed this expecting that farm boys with no training will need to service it in combat conditions. Every bolt is standard, no special tools required. The Go Devil engine displaced 134 cubic inches and produced 60 horsepower. By comparison, the Kübelwagen's engine produced 25 horsepower. The American engine was larger, heavier, less fuel efficient, and produced more power than strictly necessary. German engineers would have considered this wasteful, but Richter recognized the thinking behind it. The Americans had built an engine with power reserves, something that could handle abuse and operator error. This wasn't engineering for optimal performance. This was engineering for soldiers who would mistreat equipment and expect it to keep working anyway. Schneider examined the frame. Very heavy construction, overbuilt really. They're carrying at least 400 pounds of unnecessary weight in structural reinforcement. Richter nodded. Which means it won't break when soldiers overload it and drive it hard. They've designed for misuse. This was the philosophical difference that would define the assessment. German military vehicles were engineered to specifications, designed to perform optimally when operated correctly. American vehicles were engineered for reality, designed to perform adequately when operated carelessly and maintained minimally. Richter climbed into the driver's seat. The layout was immediately comprehensible, pedals where pedals should be. The gear shift was floor-mounted with a clear shifting pattern stamped on a metal plate. 4 forward, gears, 1 reverse, nothing complicated. Then he noticed the second lever, shorter than the gear shift, mounted beside it. This lever had 2 positions marked on a small placard, 2H and 4H. "What's this?" he asked aloud. Mueller leaned in to examine it. "Transfer case control, I think, for engaging." He traced the linkage with his eyes down into the drivetrain. His expression changed from curiosity to surprise. "Herr Oberfeldwebel, I believe this vehicle has front-wheel drive capability." Richter felt a cold realization settling over him. "You mean 4-wheel drive? All 4 wheels powered simultaneously?" "That appears to be what this lever controls." The 3 mechanics exchanged glances. 4-wheel drive systems existed in specialized vehicles. The German military used them in some heavy trucks, but these systems required careful operation and were considered too complicated for standard issue. Yet here was a light vehicle with 4-wheel drive, engaged by a single lever. No complex procedure, no multiple steps, no special training required. Just push the lever forward. Richter turned the ignition. The engine caught immediately, settling into a steady idle. He tested the clutch, shifted into first gear, still in 2-wheel drive mode, and let the Jeep roll forward. The steering felt heavy but responsive. The brakes worked well. Then he moved the transfer case lever from 2H to 4H while stopped. The lever moved easily, clicking into position with mechanical certainty. He engaged first gear again and pressed the throttle. The difference was immediate and profound. In 2-wheel drive, the Jeep had moved through the soft sand with the same labouring effort any rear-wheel vehicle displayed. But with all 4 wheels powered, the Jeep transformed. It pulled itself forward with authority, each wheel contributing to forward motion. The soft sand that required careful throttle modulation now felt almost irrelevant. The Jeep simply powered through it. Richter drove in a wide circle, testing the system in conditions that routinely trapped Kübelwagens. Soft sand that required careful momentum maintenance in German vehicles simply disappeared as an obstacle. The Jeep climbed through it at a steady pace, all 4 wheels pulling, never hesitating. He stopped and looked at Mueller and Schneider. Both men understood immediately what they'd witnessed. This wasn't just a feature. This was a fundamental capability that changed what a light vehicle could accomplish. "How many Kübelwagens could do what I just did?" Richter asked. Mueller answered honestly. "None, Herr Oberfeldwebel. In sand like this, every Kübelwagen in the battalion would struggle or become stuck. This vehicle just drove through it." Hauptmann Weber approached as they were conducting additional tests. "Your assessment?" Richter chose his words carefully. This vehicle represents a different engineering philosophy, Herr Hauptmann. The Americans have built something designed for soldiers, not engineers. It's simple, durable, and has a four-wheel drive system that any private can operate with one hand. Weber's expression darkened. Four-wheel drive? In a vehicle this size? A single lever engages it. Watch. Richter demonstrated, shifting between two-wheel and four-wheel drive while stationary. The transfer case engaged with a solid mechanical click. Weber bent to examine the mechanism. This is remarkable, he admitted. Our Kübelwagens require multiple operations just to change a tire, and most don't have front-wheel drive at all. This is troublingly sophisticated. Troublingly sophisticated. That phrase would appear in multiple German intelligence reports over the following months. Not admiringly sophisticated. Troublingly, because every piece of superior Allied equipment meant Germany's assumptions about technological supremacy needed revision. Richter spent the next 3 hours conducting systematic tests while Weber and several other officers observed. They loaded the jeep with equipment and soldiers until it carried roughly 1,200 pounds of cargo, well beyond its rated capacity. The vehicle continued to move through soft sand without difficulty. They tested the four-wheel drive in various terrain types: sand, gravel, rocky ground. In every condition, the engagement was instantaneous, and the difference in capability was dramatic. Most tellingly, they attempted maneuvers that would have destroyed a Kübelwagen. Climbing steep, sandy embankments, crawling over rocks, powering through patches of soft sand at low speed where momentum couldn't help, the jeep handled everything. Not gracefully, not efficiently by German engineering standards, but effectively. By mid-afternoon, word had spread through the reconnaissance battalion. Officers and senior NCOs from other companies arrived to examine the American vehicle. Major Friedrich Holtz, the battalion's executive officer, spent 20 minutes examining the transfer case, the mechanism. He'd studied mechanical engineering at the Technical University of Berlin before the war. "This isn't complicated," he observed to the assembled officers. "This is brilliant simplicity. They've taken a complex mechanical concept and reduced it to something any soldier can operate without training. Our vehicles require special procedures for engaging reduction gears. This requires moving one lever." He paused, looking at the officers around him. "Gentlemen, how many of these do you suppose the Americans have produced?" No one answered immediately. The answer, though none of them knew it yet, was staggering. By the end of 1942, American factories had already produced over 110,000 jeeps. Production would accelerate throughout 1943 to over 300,000 units that year alone. By war's end, total jeep production would exceed 640,000 vehicles. Germany would manage approximately 50,000 Kübelwagens across the entire war. One supply officer who had worked at the Opel plant in Rüsselsheim before the war offered his perspective. Oberleutnant Karl Hoffmann had been responsible for production logistics in civilian life. "Gentlemen, I need to explain something," Hoffmann began. "This vehicle represents a completely different approach to manufacturing. Look at this engine block. It's cast iron, not machined to fine tolerances. The Americans are accepting slightly lower precision for massive gains in production speed." He pointed to the body panels. "These are stamped steel, crude compared to our vehicles, but producible by the thousands in factories that previously made civilian goods. The Americans have converted their entire consumer economy to military production. Every design choice prioritizes speed of manufacture and ease of maintenance over engineering optimization. In a war of attrition, that approach is devastatingly effective." Major Holtz asked the question they were all thinking. "Can we match their production capacity?" Hoffmann's answer was blunt. "No. We build vehicles to achieve engineering excellence. They build vehicles to be manufactured. We require skilled craftsmen. They require semi-skilled workers following simple procedures. In peacetime, our approach produces superior products. In total war, their approach produces superior outcomes." The officers fell into uncomfortable silence. Hoffmann had articulated what many had begun to suspect. Germany's emphasis on engineering excellence was becoming a liability against an enemy with America's industrial scale. Richter spent that evening writing a detailed technical report. He documented every aspect of the Jeep's design, noting both strengths and weaknesses. The steering was heavy, the ride quality was harsh, the fuel consumption was poor, the heater was inadequate, but these shortcomings were tactical inconveniences. The four-wheel drive capability was a strategic advantage. This vehicle is designed assuming incompetent operators and minimal maintenance resources, he wrote. Every component is accessible. Every bolt is standard. The Americans have apparently decided that reliability under abuse matters more than optimal performance under ideal conditions. His report concluded, "The Jeep represents American industrial thinking at its most effective. Most concerning is that the design choices enabling easy manufacture suggest the Americans can produce these vehicles in quantities we cannot match." The report made its way up the chain of command, one document among thousands arriving at Wehrmacht headquarters as German forces encountered increasing amounts of Allied equipment. A pattern emerged. American equipment was rarely the most sophisticated, but it was almost always the most practical. Simple to operate, simple to maintain, designed for mass production and field conditions, and appearing in quantities that German intelligence found increasingly difficult to credit. The captured Jeep became prized in Richter's reconnaissance battalion. Officers competed for the opportunity to use it. Soldiers who drove it came back convinced of its superiority for desert warfare. When parts wore out, replacement components were scavenged from other captured Jeeps with remarkable ease. Every Jeep used identical parts, completely interchangeable. This interchangeability represented yet another philosophical difference. German military vehicles came from multiple manufacturers, each with slightly different specifications. Parts fit, mostly, but required adjustment. American Jeeps were manufactured by multiple companies, but the vehicles were absolutely identical. A part from a Willys Jeep fit a Ford Jeep perfectly. Complete interchangeability. This simplified logistics enormously. By early 1943, the Afrika Korps had captured dozens of Jeeps. Wehrmacht mechanics formed informal networks, sharing maintenance knowledge and scrounged parts. A black market emerged for captured American equipment. A working Jeep could command prices far exceeding its theoretical value because everyone recognized its advantages. German soldiers preferred captured Jeeps over their own vehicles for reconnaissance work. The four-wheel drive was simply too useful. Sand, wadis, rocky ground, conditions that challenged Kübelwagens were obstacles the Jeep overcame with mechanical indifference. Push the transfer case lever forward, and the vehicle powered through. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. Then came May 13th, 1943. The Afrika Korps surrendered in Tunisia. Approximately 250,000 German and Italian soldiers became prisoners. Their war was over, but their education in American manufacturing capacity was just beginning. The journey to captivity provided continuous demonstrations of Allied material superiority. American trucks transported prisoners in quantities that would have required horse-drawn wagons in the Wehrmacht. American Liberty ships, typically built in 5 to 6 weeks at peak production compared to 8 months initially, carried thousands across the Atlantic. Every aspect of the logistical operation demonstrated organizational capacity that dwarfed anything Germany had achieved. At the prisoner processing center in Oran, Algeria, Richter watched American motor pool sergeants service a fleet of vehicles with casual efficiency that would have been impossible in the Wehrmacht. The motor pool contained dozens of jeeps, trucks, and command cars. Young American soldiers, many barely out of their teens, performed maintenance with speed and confidence. Tools were abundant and readily available. Parts arrived without requisition delays. Every vehicle used the same basic components, allowing mechanics to service any vehicle without specialized knowledge. American sergeant, noticing Richter's interest, struck up a conversation in passable German. You a mechanic? I was, Richter replied. Africa Corps Vehicle Maintenance. The sergeant grinned. Well, no war for you now, but I bet you got questions about our stuff. Come on, I'll show you around. Not like you can steal anything anymore. What followed was an educational afternoon that would reshape Richter's understanding of modern warfare's industrial foundation. The sergeant, whose name was Sullivan, walked him through the motor pool with unguarded honesty. See, the thing is, we design everything so any farm boy can fix it, Sullivan explained. Most of our guys never saw a vehicle engine before basic training, so we make it simple. Color-coded wires, standard bolts, everything labeled. We got manuals written for 6th grade reading levels. He gestured to a disassembled Jeep engine. The idea is that if something breaks, anyone can fix it without calling in a specialist. We don't have time for complicated procedures or guys who need years of training. Richter examined the engine components laid out for maintenance. Every part was clearly marked with identification numbers. The maintenance manual contained detailed illustrations and step-by-step instructions that could be followed by someone with minimal mechanical knowledge. It was almost insultingly simple compared to German technical manuals that assumed significant prior expertise. How many of these do you produce? Richter asked. Sullivan shrugged. Hell, I don't know exact numbers. Thousands every week, I'd guess. They keep coming off the production lines faster than we can ship them out. We got so many Jeeps that if one breaks down bad, we usually just grab another one instead of fixing it immediately. Thousands every week. The number seemed impossible, yet the evidence was everywhere. This motor pool at one forward supply base contained more vehicles than entire German divisions had possessed. Sullivan continued the tour. Dodge trucks capable of hauling loads that would require 2 German vehicles. Half-track personnel carriers produced in quantities that made German equivalents seem like rarities. Tank transporters that could move armor without wearing out tracks. Thing is, we learned from the last war, Sullivan explained. We build everything with common components. A bolt from a Jeep fits a truck, fits a half-track. Same with electrical parts, hydraulic systems, everything. Makes logistics simple. Instead of needing 1,000 different parts, we need maybe a couple hundred. And we produce them by the millions. This was the secret that German manufacturing had never fully grasped. Component commonality wasn't just about production efficiency. It was about creating a logistical ecosystem where any part could be used anywhere, any mechanic could service any vehicle, and the entire system reinforced itself through standardization. Richter thought about the Wehrmacht's vehicle inventory. Dozens of different truck types from different manufacturers, each with unique parts and maintenance requirements. Kübelwagens from Volkswagen, command cars from various sources, captured vehicles from across Europe. German logistics were a nightmare of incompatible systems. American logistics were streamlined through uniformity. The real genius, Sullivan continued, is that we designed for manufacturability from the start. When they put out requirements for the Jeep back in '40, they gave companies just 75 days to produce a prototype. American Bantam did it in 49 days. Then, Willys and Ford refined the design for mass production. He patted the Jeep's hood. Everything had to be simple to manufacture, simple to maintain, simple to repair. No sophisticated solutions that slow down production, just good enough engineering that works reliably and can be built by the millions. Richter had examined enough Jeeps to recognize this truth. The vehicle wasn't elegant. German engineers would have designed something more sophisticated, but sophistication impeded mass production, and mass production was winning the war. The journey from North Africa to American prison camps continued Richter's education. At every stop, prisoners witnessed American production operating at scales that defied German preconceptions. The port at Norfolk, Virginia, processed thousands of tons of supplies daily. Trains carried prisoners across America in passenger coaches, and everywhere, vehicles. Cars filled parking lots outside factories. Trucks lined highways in convoys stretching for miles. Military vehicles sat in depot yards by the thousands. At Camp Swift, Texas, skilled mechanics were offered the opportunity to volunteer for motor pool work. American camp commanders welcomed their expertise because the war effort demanded every available skilled worker. For Richter and dozens of other former Afrika Korps mechanics, this meant spending the next 2 years maintaining vehicles that kept the camp operational. Working alongside American soldiers provided insights that no intelligence briefing could have delivered. American mechanics approached vehicle maintenance with direct practicality. They weren't engineers striving for perfection. They were problem solvers focused on keeping equipment operational. When something broke, they fixed it quickly. When parts weren't available, they improvised. When a vehicle proved unrepairable, they cannibalized it and requested a replacement, which arrived within days. German mechanics had been trained to maintain vehicles to factory specifications. American mechanics were trained to keep things running by any means necessary. In peacetime conditions, German methods produced better results. In wartime chaos, American methods proved vastly more effective. The motor pool at Camp Swift processed hundreds of vehicles monthly. Jeeps came in for routine maintenance, received service in hours, and returned to operational status. The efficiency came from parts abundance and component interchangeability. When a part needed replacement, the parts room had dozens in stock. When a tool was required, the tool crib provided it immediately. Richter befriended an American soldier named Robert Chen, who had worked for Ford before the war. Chen proved knowledgeable about American automotive manufacturing and willing to discuss it openly. Before the war, I worked on the assembly line at Willow Run, Chen explained during a break one afternoon in June of 1944. That's Ford's bomber plant outside Detroit, biggest factory in the world. We're building B-24 Liberators. Started production in '42, and by the time I got drafted last year, we were completing 1 bomber every hour. Richter did the mathematics in his head. 24 bombers per day, over 700 per month from one factory. How is such production possible? He asked. Mass production principles, Chen replied. Mr. Ford figured out how to break down complex manufacturing into simple, repeatable steps. You don't need skilled craftsmen if every worker does one simple task repeatedly. A kid fresh off the farm can be trained in a week to install one type of bolt in one specific location. Do that with 1,000 workers, and you get massive output. This was the fundamental difference. German production relied on skilled craftsmen building quality products in moderate quantities. American production relied on semi-skilled workers building adequate products in massive quantities. Same thing with Jeeps, Chen continued. Willys Overland makes them, and so does Ford. Both plants use identical specifications. A part from a Willys Jeep fits a Ford Jeep perfectly. They're completely interchangeable. That means if one plant gets bombed, the other keeps producing. Maintenance is simple because every mechanic learns one vehicle, not dozens of variants. By summer of 1944, news reached the camp of Operation Overlord, the Allied invasion of Normandy. The scale defied comprehension. 6,000 ships, 11,000 aircraft, 150,000 men in the first wave. Within weeks, millions of Allied soldiers would be fighting in Europe, all supplied by a production base that created equipment faster than the Wehrmacht could destroy it. Richter reflected on the confidence Germany had possessed in 1939. That confidence had been based on assumptions about German technological superiority. Those assumptions weren't entirely wrong. Germany did have superior engineering in many areas. German tanks were more heavily armoured. German aircraft were often more sophisticated. German small arms were excellent, but none of that mattered when America could produce 5 tanks for every 1 Germany built, 10 trucks for every German truck, 100 jeeps for every Kübelwagen. In the motor pool one afternoon in August, Richter watched American soldiers loading jeeps onto transport trucks for shipment to the port. Dozens of vehicles loaded in less than an hour, all bound for Europe. This single loading operation at one camp in Texas represented more vehicles than his entire division had possessed in North Africa. And this scene was being repeated at camps and depots across America every single day. The mathematics became inescapable. Germany had mobilized its economy for total war, stripping civilian production to support military manufacturing. Yet German military vehicle production in 1943 totaled less than 100,000 units of all types. America, while maintaining a thriving civilian economy, produced over 2 million military vehicles in 1943 alone. The disparity wasn't just quantitative, it was qualitative. American vehicles were designed for wartime realities: ease of maintenance, interchangeable parts, simple operation, rugged reliability. German vehicles were engineered to specifications that made sense in peacetime, but proved impractical in sustained combat. News reached the camp in December of 1944 about a German offensive in the Ardennes, the Battle of the Bulge. Hitler's last gamble relied heavily on capturing American fuel supplies because Germany no longer had sufficient fuel to sustain armoured operations. The offensive included Operation Greif, Otto Skorzeny's commando operation using captured American equipment. German soldiers, equipped with captured jeeps and American uniforms, were tasked with infiltrating Allied lines. The irony wasn't lost on the German mechanics at Camp Swift. Even Skorzeny, Hitler's favourite commando, was now reduced to depending on captured American vehicles because German vehicles were insufficient. The operation failed, and the Ardennes offensive itself ground to a halt because German forces literally ran out of fuel. Panzer divisions abandoned their tanks when fuel trucks failed to arrive. Spring of 1945 brought news of Germany's collapse. The Red Army closed on Berlin from the east. American and British forces crossed the Rhine and drove deep into Germany from the west. In the Camp Swift motor pool, German mechanics continued their work, maintaining vehicles for an army that had defeated their homeland. One afternoon in April, an American guard approached with news. Germany surrendered. War's over in Europe. The mechanics nodded. They had expected this for months. "What happens to us now?" Richter asked. "You'll go home eventually, probably not immediately, but you'll go home. Home to a Germany that had been bombed into rubble, occupied by foreign armies, its cities destroyed by the same manufacturing might that had produced the Jeep." The American asked, "You're a smart guy. Did you really think Germany could win?" Richter thought carefully. "Before the war, yes. We believed German quality would overcome American quantity. We had seen American products before the war, and many were inferior to German equivalents. We assumed American military equipment would be the same." He paused, remembering that morning in November of 1942. "But when we examined that first Jeep in 42, when I pushed that transfer case lever forward and felt all four wheels pulling, I realized we had made a fundamental error. We had confused peacetime quality with wartime effectiveness. Your Jeep wasn't better engineered than our Kübelwagen in absolute terms. It was better designed for mass production and field conditions. In total war, that proved decisive." The repatriation process began in late 1945. Richter arrived in Bremen in January of 1946. The city was ruins. Rubble stretched in every direction. But amid the destruction, he noticed something. American vehicles everywhere. Jeeps carrying Allied officers through the shattered streets. Trucks delivering relief supplies. Motor pools where Germans worked alongside Allied soldiers. He approached one motor pool, introducing himself to the American captain in command. "Sir, I am former Oberfeldwebel Klaus Richter of the Afrika Korps, recently repatriated from Camp Swift, Texas. I am a trained vehicle mechanic with experience maintaining American equipment. Are you hiring civilian workers?" The captain examined his papers. "Says here, you worked in our motor pool in Texas. That right?" "Yes, sir. 2 years. We need mechanics desperately. You can start tomorrow. Pay is in occupation scrip." And so Richter found himself employed by the army he had fought against, maintaining the same vehicles he had once examined as enemy equipment. The Allies needed mechanics. He needed work. The war was over. Life continued. Over the following months, he witnessed the beginning of Germany's reconstruction. American aid poured in through the Marshall Plan, distributed with the same efficiency that had won the war. Food, medicine, construction materials, all arrived in American trucks. Richter worked in the motor pool, training young Germans in American maintenance techniques. Many of his students were former Wehrmacht soldiers, men who needed civilian skills. He taught them what he had observed: simplicity over sophistication, functionality over perfection, results over theory. These were lessons learned from American vehicles, applicable to rebuilding German society. By 1947, Richter had been promoted to supervisor of the motor pool's German civilian staff. The American captain who commanded the facility, Captain Morrison, treated him with professional respect. One evening, Morrison invited him to share a drink. "You've worked with both German and American vehicles extensively," Morrison said. "If you were designing a vehicle for the new Germany, what would it look like?" Richter considered carefully. "I would adapt the American approach for European conditions. Smaller than a Jeep, more fuel efficient, suitable for narrow European roads. But maintaining the same philosophy: common parts, simple maintenance, designed for manufacturing efficiency, rather than engineering perfection." Morrison nodded. "That's smart. Marshall Plan money will rebuild German manufacturing, and German engineers are already studying American methods. The future is combining American production efficiency with German attention to quality." This proved prophetic. In the decades that followed, West German manufacturing did exactly that. Companies like Volkswagen evolved into global automotive giants by synthesizing American mass production techniques with German engineering precision. The Volkswagen Beetle embodied this synthesis perfectly: simple, reliable, manufacturable in huge quantities, and affordable. Ferdinand Porsche's original design, refined through lessons learned from both German engineering tradition and American production philosophy. Former Wehrmacht mechanics who had worked in American prison camp motor pools returned to Germany with knowledge that proved invaluable. They understood component standardization. They had witnessed efficient parts distribution systems. They had seen how simplified maintenance procedures increased vehicle availability. They had observed how designing for manufacturability enabled mass production. By the early 1950s, this hybrid approach was producing remarkable results. Volkswagen production ramped up from thousands to hundreds of thousands. Mercedes-Benz adapted assembly line techniques while maintaining quality. BMW restructured manufacturing to emphasize component commonality. The economic miracle of the 1950s and 60s owed much to these changes. West Germany became an export powerhouse, selling vehicles that combined reliability with affordability. In 1967, Richter attended a reunion of former Afrika Korps soldiers captured in Tunisia. Over dinner, conversation turned to the vehicles of the war. "The Kübelwagen was excellent," one veteran offered. "Lighter, more fuel-efficient, well-designed for desert conditions." Richter nodded. "It was excellent, yes, but the Jeep was better suited for modern warfare. Four-wheel drive, simpler maintenance, common parts, and most importantly, producible in quantities we could never match." Another veteran added, "I remember the first time I drove a captured Jeep, November of '42. We thought it was crude. Took us months to understand that the simplicity was sophisticated thinking. By '43, every unit wanted captured Jeeps because they simply worked better." An old officer spoke up. "The worst moment for me was realizing that America was producing more Jeeps in a week than Germany produced Kübelwagens in a year. That's when I knew we would lose. Not from any particular battle, but from simple mathematics. They could replace losses faster than we could inflict them." This was the consensus. German soldiers had tremendous respect for the Kübelwagen, but they recognized that the Jeep, and what it represented about American production capacity, had been decisive. Through what it revealed about the unbridgeable disparity in manufacturing capability, the four-wheel drive system that had so impressed Richter in 1942 became standard on many vehicles in post-war years. What had been a specialized feature became commonplace by the 1970s. German manufacturers incorporated four-wheel drive into civilian vehicles, creating markets that hadn't existed before the war. The principle behind the Jeep's simple transfer case, one lever engaging all-wheel drive, was refined but not fundamentally changed. Modern vehicles use more sophisticated systems with electronic controls, but the core concept remains. When you need more traction, power all the wheels. By the 1980s, Richter was retired, living in Bremen in a rebuilt city that bore little resemblance to the ruins of 1946. West Germany had become one of the world's leading economies. German automotive companies exported millions of vehicles annually. German manufacturing was synonymous with quality and reliability, but that quality was now paired with production efficiency that owed much to American influence. The synthesis had worked. Germany had combined its traditional engineering excellence with American mass production methodology, creating an approach that served it far better than pre-war methods. In his small apartment, Richter kept a photograph from 1942. The image showed him standing beside a captured jeep in the North African desert, taken shortly after they'd discovered the four-wheel drive system. He was young in the photo, confident, still certain that German superiority would prevail. Looking at that photograph decades later, he saw the moment when his education in reality had begun. The Jeep had been more than a vehicle. It had been a teacher. It taught that assumptions about superiority need examination. That functional effectiveness matters more than sophisticated design. That designing for manufacture and maintenance serves better than designing for perfection. Those lessons helped transform Germany from defeated enemy to prosperous ally. The mechanics who admitted they had never had vehicles like the Jeep became architects of renewal. Their humility, born from defeat and educated by observation, served Germany better than the pride that preceded catastrophe. In November 1942, examining a captured Jeep in the North African desert, Wehrmacht mechanics began a journey of discovery that would influence a generation. That admission, that moment of recognizing something genuinely superior in enemy equipment, marked the beginning of wisdom that rebuilt a nation. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.